Hello one and all, and welcome to the Math Magic Show. On this one, we are going to find this limit. When you see it, you might say, it looks kind of hard, but is it really? You should pause the video and try it on your own, okay? Try it, but I'll pretend. Okay, and I'll do it. So, take a look. Limit as x approaches a of x squared minus a squared over x to the fourth minus a to the fourth. Well, hopefully you can tell by looking at the nature of the expression in the numerator and denominator. These expressions are screaming to be factored, right? X squared minus a squared. So let's do it. I'm going to have the limit as x approaches a. Now in the numerator, don't factor, just leave that as x squared minus a squared. When I say factor, I mean factor the denominator more specifically. Why? Because it's x to the fourth minus a to the fourth. So that can be, in other words, written as follows at first. It's x squared squared minus a squared to the second, like this. You can first rewrite the denominator expression in that form. And then from here you can do some stuff. So let's see, what's the magic? The limit as x approaches a of x squared minus a squared divided by... Now here, this is a difference of squares, hopefully you can tell. That's a difference of squares. This is, I mean the squares with respect to the outside, this one and this one. You see? So that pattern, as a reminder, holds. How does it hold here in this particular expression? Well, remember, the pattern says if you have whatever squared minus some other quantity, whatever squared, it becomes x minus a times x plus a. That's the pattern. The pattern doesn't tell you that x has to be x to the first. It could be x to the whatever. Same thing with the other one. So here, it's going to look like this. It's going to be x squared minus a squared. And then it's going to be the following next, x squared plus a squared. That's the particular application of the difference of squares when you're beginning with x to the fourth minus a to the fourth. It takes that form in the denominator. And then from here you can proceed. So nice thing is, look, this cancels with this, leaving up here, as I'm sure you know, a positive 1, right? There's a 1 left over in the top. And then let's see. So at the very end we have the following pretty much. The limit as x approaches a of 1 divided by x squared plus a squared, this way. All right, friends. I bet you know what to do by now, because I know that you paused the video when I said to do so, and you worked through it, right? So now we're going to have 1 over, and then replace x directly with a. No division by 0 or anything shaky like that. So you're going to have, in other words, 1 over a squared plus a squared, which lastly will then become 1 over 2a squared. And this here, friends, is our answer, 1 over 2a squared. That is the value of the limit found according to these steps. This is a question from an older AP Calculus BC test. I like this question. Let's see, because you got to know how to factor, right? You got to know how to cancel. You got to know how to take a limit with direct substitution at the very end, and all that stuff. I like questions that kind of test multiple skills at the same time. They're a lot more interesting, right? I'm going to leave it here, so please leave a like, please subscribe, please share, leave some comments down below, and I will see you in another video.